Hello friends, today we discuss about some examples. Okay, now friends, this example is very useful in your examination, right? Okay, see here. Use the mirror equation to deduce that first, an object placed between f and 2f of a concave mirror produce a real image beyond 2f. Second, a convex mirror always produce a virtual image independent of the location of object. Third, the virtual image produced by a convex mirror is always diminished in size and is located between focus and the pole. And last, an object placed between the pole and focus of a concave mirror produce a virtual and enlarged image. Right. Now friends, here we have to use the mirror equation. We know the mirror equation, 1 by u plus 1 by v is equals to 1 by f, right? So here we have to discuss about concave and convex mirror. So friends, we know that the focal length is positive for convex mirror, right? So for convex mirror f is equals to positive, and for concave mirror f is negative. Yes, okay, this is very useful question. For convex mirror focal length is blank, and for concave mirror focal length is blank. So you have to remember this. For convex focal length is positive, and for concave focal length is negative. Okay, now here in our first case, so for A, now see, an object placed between f and 2f. So we have to put object between f and 2f of a concave mirror. So f and 2f both are negative. Produce a real image beyond 2f. So we have to prove that the image distance is beyond the 2f, right? Okay. Now friends, we have to put an object between f and 2f. So here for concave, for concave mirror, f and 2f both are negative, right? Okay, so we know the mirror formula. So mirror formula, 1 by u plus 1 by v is equals to 1 by f. Here we have to find the image distance, right? We have to prove that real image is beyond 2f. So here we formulate v. So we can write that 1 by v is equals to 1 by f minus 1 by u, right? Okay. Now friends, here we place an object between f and 2f. So u is between f and 2f. So here we can write like this, 2f less than u less than f, because u is between f and 2f, right? Okay, here f is negative, so we write that 2f less than u less than f. But we have to find out v. So here we have to make an equation in terms of v. So we have to prove relation between u and v. So here the equation is 1 by v is equals to 1 by f minus 1 by u. So here we have to take the negative sign and take the inverse of u to prove the relation, right? So here in this step 2f less than u less than f. We take inverse and take a negative sign. So we have to write like this: minus 1 upon 2f less than minus 1 upon u less than minus 1 upon f. Right? Here we take minus, so minus and take inverse, so we can write like this: minus 1 by 2f less than minus 1 by u less than minus 1 by f. Here to prove 1 by v, the equation is 1 by v is equals to 1 by f minus 1 by u. So we have to add 1 by f in each term, right? So by adding 1 by f in each term, so 1 by f minus 1 by 2f less than 1 by f minus 1 by u less than 1 by f minus 1 by f. Right? Here we have to take LCM between f and 2f, which is 2f. So here f, so multiply by 2 minus here 2f, then 1. We know that 1 by f minus 1 by u. See here 1 by f minus 1 by u. So 1 by v. 1 by v less than 1 by f minus 1 by f, 0, from equation 1. Okay. Here 2 minus 1. So 2 minus 1, 1. So 1 upon 2f less than 1 upon v. So 1 upon 2f less than 1 upon v. Right? So by cross product, so v less than 2f, we can write like this, or we can also write that 2f greater than v. But here we know that 2f and v both are negative, so we can say that hence real image is obtained beyond 2f, right? Because 2f and v both are negative. Okay, you understand this? Now we discuss about our second case. So for b, now see our second. A convex mirror always produces a virtual image independent of the location of the object. So friends, we have to prove that convex mirror produces a virtual image. Virtual image, we can say that if v is greater than 0, image distance is greater than 0, then we can say that the image is virtual, right? So we already know the mirror equation, and 1 by v is equals to 1 by f minus 1 by u. So from mirror equation, 1 by v is equals to 1 by f minus 1 by u. But here the given mirror is here. We have to prove this for convex mirror, right? So we know that for convex mirror f is positive, so greater than 0, and u is negative, so u less than 0. So we can write that for convex mirror f is positive, so f is greater than 0, and u is negative, so u is less than 0, right? So here you can see in this equation 1 by f, f greater than 0, so 1 by f is positive, minus 1 upon u, but u is negative, so minus minus here plus, So 1 by f minus 1 by u greater than 0, we can say that. So we can also say that then 1 by V is greater than 0, right? So for convex mirror, F greater than 0, U less than 0, so V greater than 0. So we can say that hence V greater than 0, and it represent that any value of U, virtual image, is obtained by a convex mirror. Okay, so this is our second case for convex mirror, right? Now third case for C. So the virtual image produced by a convex mirror, once again we have to deal with convex mirror, is always diminished in size and is located between the focus and the pole. So we know that if the magnification is less than 1, then the size is diminished, and if magnification is greater than 1, then the size is enlarged, right? So here we have to prove that the virtual image produced by a convex mirror is always diminished. So we have to prove M magnification less than 1, right? Okay. And located between the focus and the pole. So we have to find out the image distance between focus and the pole. So we have to prove that the image distance is less than focal length. So we can say that it is located between focus and pole, right? So once again from the mirror formula, right? Now for C. For C, once again from the mirror formula or equation, 1 by V is equals to 1 by F minus 1 by U, right? Now friends, here we discuss about the convex mirror. Once again we know that for convex mirror, F focal length is positive, object distance is negative, and image distance, here we prove that, is greater than 0. So we can say that image distance is positive, right? So see here focal length is positive, so we can write that 1 by V is greater than 1 by F. Why? So you can see in this equation 1 by V is equals to 1 by F, which is positive, minus 1 by U, but here for convex mirror U is negative, so minus minus plus, so we can say that 1 by V is greater than 1 by F, right? Okay, so we can write that. Here V greater than 0, U less than 0, and F greater than 0, right? So 1 by V greater than 1 by F, by cross product F greater than V, or we can say that V less than F. So if V less than F, then we can say that the image is obtained by this mirror is between focus and the pole. So the image obtained by the mirror is between focus and the pole, right? So this is done, that the virtual image is produced by convex mirror is located between the focus and pole, but we have to prove this image is produced by a convex mirror is always diminished. So we have to prove that magnification is less than 1, right? So for this we have to again deal with the mirror equation. So from the mirror equation, once again equation 1 by v is equals to 1 by f minus 1 by u. Now friends, see here, 1 by v is greater than 1 by f, and we can also say that 1 by v is greater than minus 1 by u, right? So 1 by v is greater than minus 1 by u. We know the formula of magnification, m is equals to minus v by u. So here we multiplied both sides with v. So we can write that by multiplying v on both sides. So we can write that v by v greater than minus v by u. So here 1 greater than minus v by u, but we know that m is equals to minus v by u. So 1 greater than m, or we can say that m here, m is equals to minus v by u. So 1 greater than minus v by u m, or m less than 1. So we can say that hence diminished image obtained, right? Okay, now we discuss about our last D. So we can write that for D. Now see here, an object placed between the pole and focus of concave mirror. So now we have to deal with concave mirror. Produce a virtual and enlarged image. We know that if v greater than 0, then the image is virtual, right? And if magnification is greater than 1, then we can say that the image is enlarged, because m is equals to minus v by u. We know, right? So here we have to deal with concave mirror. So once again from the mirror formula, so from mirror equation, right, we know that the equation 1 by v is equals to 1 by f minus 1 by u, right? Okay, now for concave mirror we know that f is negative, but u is also negative. So f is negative, u is also negative, then we can say that here in this condition 1 by f minus 1 by u is greater than 0. Why? So we know that u is greater than f, right? Object distance is always greater than focal length. So we can say that for concave mirror, f is less than 0, and here in this given condition, here the object is between pole and the focus of a concave mirror, right? So we can say that and object is between C and P, then we can say that u is greater than f. So here if u is greater than f, so 1 by f minus 1 by u greater than 0, right? Why? Because 1 by f is negative but u is negative, minus minus plus, so answer is positive. So 1 by f minus 1 by u greater than 0, then we can say that 1 by v greater than 0. If 1 by v greater than 0, then we can say that v is greater than 0, right? So hence real image is obtained, or we can say that virtual image is obtained. Now we have to also prove that the image is enlarged. So we have to prove that m is greater than 1, right? So once again, from the mirror equation, from the mirror equation, 1 by v is equals to 1 by f minus 1 by u. See here, 1 by v is equals to 1 by f minus 1 by u, but we know that for the concave mirror, you also studied the mirror formula, so we can say that from the mirror formula or for the concave mirror, 1 by v less than minus 1 by u, right? So we can say that multiplying both sides by v, 1 less than minus 1 by u, so 1 less than m, or we can say that m is greater than 1. So the image is enlarged, right? Okay, so this is important sum which asks in 2 marks, 3 marks, 4 marks or 5 marks, right? Okay, now see our next example, example number 16. A small pin is fixed on a table top, is viewed from a distance of 50 cm. By what distance would be the pin appear to be rise if it is viewed from the same point through a 15 cm thick glass slab held parallel to the table? Here refractive index of glass is equals to 1.5, and does the answer depend on the location of the slab? We have to answer this. So friends, here it is view from the same point through a 15 cm thick glass. So here we have to view from the same point through a 15 cm thick glass. So here the real depth is given, which is 15 cm, right? Here this distance is given for to confuse us, right? So here it is viewed from the same point through a 15 centimeter thick glass. So here real depth is 15 centimeter. So here we have to answer that by what the distance would be the pin appear to be rise. How much the shift of pin or how much rise of the pin. So we have to find out the apparent depth first, right? Okay, our first medium and second medium is glass. So friends, we already know the formula. We studied that refractive index of rarer medium upon diffractive index of denser medium is equal to real depth is equals to apparent depth upon real depth, right? So friends, here we already studied this. So here rarer medium refractive index 1 of error, so 1 upon n is equals to apparent depth. Here we have to find out the apparent depth. So here we take apparent depth h upon real depth. Real depth is 15, right? So we can say that h is equals to 15 upon n. So 15 upon refractive index of glass 1.5 is equals to 15 upon 1.5, 10. So we can say that height is equals to 10 centimeter. Which height? So this is our apparent depth. So we can write that apparent depth is equals to 10 centimeter. But we have to find out the shift. So we can say that shift of pin. So here the original depth is 15 centimeter, you can see 15 centimeter, and the apparent depth is 10. So shift is 15 minus 10, which is 5 centimeter, right? So we can say that shift of the pin is 5 centimeter. Now here we doesn't use the location of this slab, so we can say that does the answer depend on the location of slab? So we can say that answer doesn't depend on the location of slab. So we can write that answer doesn't depend on the location of slab, right? Okay, thanks friends.